Hello everyone, and welcome to the LAN Ranger. So I've been wanting to kind of discuss this topic for a while because it's something that I deal with every day. And I know there's a lot of interest in it because I see a lot of articles and questions on the forums about this. So today we're going to be going over Extreme's Fabric Extend over IP, which is a method for you to be able to extend Fabric Connect services across maybe like a Metro Ethernet, like an E-line, which is like a virtual private wire service, or an ELAN, which is a virtual private LAN service, or an E-tree even. And we're going to be talking about various ways to configure Fabric Connect over IP, which is known as Fabric Extend. So it's essentially extending your campus fabric across some form of IP transport. Now, there's several ways to approach it, and there's a lot of ways to do it. And I'm not going to go into the super detailed complexity over it. We will talk about, MTU issues with this and how we could also create multiple adjacencies off of a single port, which is of course like an E-tree setup for Metro Ethernet. We will discuss, with the jumbo frames and fragmentation. So, you definitely don't want a Linux box sitting northbound of your Fabric enabled switch and doing software-based fragmentation. You definitely want ASIC designed hardware in order to be able to do proper fragmentation, or your performance will suffer. And of course, all those things we'll try to cover in this video, and I'll try and give some suggestions and things that I do as best practices when extending my campus fabric over an IP transport. So first things first, I'd like to show what kind of like an E-tree would look like in this scenario. So we could just call this CPE1, CPE2, and CPE3. So we could say maybe this is like a 5420, or I don't know, a VSP7K or something, just hypothetically, right? And we've got our customer premise equipment, which it could be whatever your service provider gives you, which is going to two different CPEs, and we have been tasked to extend Fabric Connect between these branches. Assuming this is like a Q&Q or jumbo, or jumbo frame WAN, you can't have multiple adjacencies on one interface. So let's just say that this one is interface 1.1. That branch A cannot form an adjacency with C and B like this. We can shut this port here. So we could say this port is shut, and then the adjacency would form with this one, but we can't have branch C on the same interface. It will just stay in an init state, and it won't actually surpass that state. So it'll never actually form that adjacency. We do have the ability to use FEoIP, which is what this video is about. And that's where we will encapsulate the BVLANs, or the backbone VLANs, in Fabric inside of a VXLAN. So we actually take and make 4051 and 4052 if you use those as your BVLANs, but both BVLANs will actually be VNIs for the VXLAN. And that's where we could actually have a logical adjacency between these sites. So now we'll have a single interface here for SPB OIP, and we'll actually have this single interface. We'll see multiple adjacencies, and that's where Fabric Extend over IP comes in. So we'll kind of show, if you're trying this in a lab, or maybe you're trying this in production, you've never done this before, we'll kind of show what happens if you were to actually try and get an adjacency without having FEoIP, and you just wanted to see what it looked like with, or how it would behave if you had two different Fabric Engine switches, or VOSS, that were trying to form an adjacency off a single port. And then of course, we'll go through the actual configuration. We'll also do FEoIP between through FortiGates over the public internet. And then we'll just do a logical adjacency, which is where you have the layer 2 in between, like a transparent uni. And then kind of see how this plays out. And yeah, hope you enjoy. All right, so first things first, this is a sample topology that I kind of built. So we've got two ISPs, CPE equipment, ISP owned, can't make any changes to it. This is just a simple transport that, maybe you have no visibility into this network. They just say, hey, you got 2 ports at these 2 sites and 1 port at the other site, right? You should know what they're giving you, but let's just say you don't have any visibility into it, or maybe it's just a ELAN, and you want to form an adjacency over it. And of course, this is layer 3. And the ISP routers don't even need to know the destination IP or the IPs in between. If they're providing you a layer 3 service, you would be able to take advantage of that. But since this is just a layer 2 point-to-point, we don't necessarily need to worry about that. But as you can see, that's being learned on port 11. So if I look at 1, of course, we've got just 1 gig, nothing special, right? If I do VLAN, we could look at the VLAN. That is our SPB VLAN. So what I'm going to do is I'm going to go in here and I'm going to turn VLAN members remove 999.11. Oh. Turn on auto NNI on that interface, and we'll do the same thing on Backbone Edge Bridge 5. All right. So Backbone Edge Bridge 5, if we come back over here, we can do show int gig auto sense. And then show ISIS adjacency. I think I need to wait for that to come up. Or did I do that over here? Oh, never mind. Oops. Okay. What did I set that to? I don't remember what interface that was. 1, 2. INT gig 1, 2. 1, 2 auto NNI. I think I'd forgotten to turn that on. There we go. All right, so right now we just have a plain NNI port. So if I do show run mod port, and we look at 1.7, auto NNI simply adds, ISIS, SPBM1, and ISIS enable. So it'd be the same thing over here for 1.2. And then auto NNI, of course, that would, you could convert that to config, but it's the same thing. It's just SPBM. So as you can see here, we no longer have the other BEB node, which is S4. We can look at the logical interface, and of course there's no adjacency between these using the logical interface. And then they're both up. So if I do show ISIS adjacency, it's been up for 56 seconds. And the whole time, we got 23 seconds left. So what I'm going to do is the same thing on, make sure I got the right port. Yep, I'm going to do the same thing on the S4 BEB. So auto sense enable, no auto sense enable to clear that port config, and then auto NNI. Now that auto NNI is on there, we'll just refresh this and see what happens. I think I chose the right port, didn't I? Yeah. Two core. And this should start flapping, or we may not even see it come up. Yeah, there we go. So it'll just start flapping at this point. It'll go down, it'll come up, it'll go down. We'll never actually build the adjacency with the S4 BEB. And see, that one built an adjacency with S5. It just behaves so wonky when you do this. So see, S5 no longer has an adjacency with the core. Yeah, it's very interesting, and see how they're just flapping. It's very interesting how that works, but you can't actually build an adjacency in that fashion. So, all right, so we've switched to another topology here. This is actually my MPLS lab with Extremes XOS. It's a little mix of OSPF and MPLS. There's not very much traffic engineering going on, but I thought it would be interesting to kind of showcase this topology. So first things first, we have our core VSP, and we've got a VLAN, which is a layer 2 VSN. We show VLAN ISID. We have an ISID assigned to that VLAN. So if we do show IS LSDB all, what is that? There we go. We can see we've got the TLVs being learned. See if I can find, where is that? Okay, site to core is a host name. Excuse me. So if I do show ISIS SPBM ISID all, we can see that ISID that I have created on that layer 2 VSN number 2 is being learned from site 2 core and core VSP, respectively. So if I show ISIS adjacencies again, we've got our site 2 core, show ISIS logical adjacencies or logical interface. We could see that port 17 is actually where that logical adjacency is terminated. We've named it to site, and the destination of that tunnel IP is 15.15.02. If we come over here and look at, I think that's ENS4, show IP interface, and we do a ping back to our site 2 core. Yeah, there we go. Let me open that. All right, so this is actually what the packet looks like. Of course, we got our layer 2, layer 3, layer 4, and then here's VXLAN. As you can see, if you know Fabric or SPBM, if I do show VLAN ISID, this is an even ISID number, which means that traffic will actually traverse over the BVLAN 4052. So traffic that you have with even ISIDs will traverse over the even BVLAN, and if you have an odd ISID, you will traverse the odd BVLAN. So 4051 for like VLAN 1 and 4052 for VLAN 2 respectively. And then inside of VXLAN here, we've got our layer 2, which is the actual source and destination of this traffic, wrapped around with our BVLAN, and then we've got the destination ISID and all that good stuff. And then inside of that, we actually have our ping with ICMP. And of course, wrapping around that, it would be the same on both sides, so the other side would respond in the exact same way. Let's do count 10. And we get our responses back just like that. So if I come up here, let's collapse all. So you can see this is actually wrapped in that FEoIP destination 15.15.02 and 15.15.01. So the source will be 2 and the destination is 0.1. And that's how it works. It's that fancy. It's quite simple to understand its inner workings. It's a pain to troubleshoot, but it's pretty easy to stand up and configure. I just wanted to show what that looked like from a packet capturing perspective. All right, well, if you've made it this far, then we're now ready to configure two Fabric Engine switches with a logical adjacency over the public internet. So the idea here is that we have an IPsec concentrator. Assume that we have an IPsec concentrator with a NAT device or something that has internet reachability between sites, right? So in this instance, I would typically do something like a /30 point-to-point between said device, so that you would be able to use that as your tunnel source, and you would also be able to use that other side for your tunnel destination. So we'll log into VSP switch 2. This is a totally factory default, and the first thing that I do with a factory default VSP is I SNMP server set a name, and let's just call this core, and that looks good. Disable screen logging because we don't need that. And then where is my... Forgot what I was going to name the other one, but I now know. So do the same thing over here. Now remember, this is all virtualized, so it's as far as the extended architecture goes, there are a lot of limitations. So, site to core, I think. Yep. Perfect. So, like I said, we've got a /30 for each side, and we'll be creating those on both switches. So the first thing we will do is show run mod VLAN, look at our existing VLAN configuration, and there is none. We want to create our point-to-point VLAN. I like to call it SPBOIP. Interface VLAN 10, VRF SPBOIP. Forgot to create that VRF, so IP VRF SPBOIP, interface VLAN 10, VRF SPBOIP. Now if we do show run mod VLAN, we now have a VLAN, and we've got that VLAN assigned to the VRF SPBOIP, and to create that VRF, we do IP VRF and SPBOIP. It'll automatically assign a VRF ID. But if you wanted to, you could specify one. Now, if you're wondering why I am doing a VRF, is because I do not want the redistribution for IP shortcuts to advertise the tunnel source addresses. So we don't necessarily want it in the global routing table, or we would have to use a route map or accept policies to prevent that. So as you can see here, we have no IP interface. So there is no IP interface configured, which basically means that we don't have any layer 3 at all. Assuming that our NAT device or VPN concentrator, whatever our router is, wherever we got that /30, we could assume that it's untagged, hopefully. So what we can do is interface VLAN 10 and give it an IP address. And based on our topology, it's 10.110.0.0/30, which should mean that we could say 10.0/30. Let's give it .2. And if I run show IP interface, I don't actually see that interface. But if you notice, the IP interface here is -global router. No, it's not in the global router. Show IP interface VRF SPBOIP, because that's the one we created, and there it is. As you can see, its operational state is down, but that's because if we do show VLAN members, VLAN 1 is the member of everything, or everything's a member of VLAN 1. We don't necessarily want that. We do want one interface specifically, and that will be interface 1. So VLAN members add, 10, 1, 1. Now, if I do show int gig VLAN 1, 1, we have no encapsulation .1q. It's untagged by default. So what we could do is we could try and ping, and there's nothing. So we can't actually ping that. So I don't remember if I had encapsulation enabled. Now, you can use a brouter port. The reason I'm not using a brouter port is because I'm assuming that maybe something that is doing the fragmentation and IPsec tunnel terminal or termination would likely be doing other VLANs, right? Maybe it's a router on a stick topology or what have you. And so a brouter port is, of course, a single, consumes a single VLAN, right? But I would prefer to just do it like this. Let's see if we can ping that now. Oh wait, I'm pinging in the context of GRT. Golly, man. SPBOIP source 10 to interface is down. We like to run into problems. Oh. Boy howdy. Always layer 1, huh? Okay. That's fun. Not actually sure what I did there. Uno momento. No, so that was a silly mistake. I don't want to talk about it. It was actually northbound on the router side, but yeah, we're all good now. So, as you can see, we can ping the .1, which is our VPN concentrator. So if I do show IPR VLAN 10, SPVOIP, we got our .1. So what I want to do now is I want to be able to reach the other side. So for example, maybe the network administrator on the other side of this says, hey, we have our other our security associations configured, so maybe you can ping the other side now, right? Let's try that. So the first thing I'm going to do is try to ping the other side that he gave us, VRF SPVOIP. And what you'll notice is that it's not reachable. And if I show the routing table of that VRF, you'll notice we're missing one thing. That is an important thing because that is our default route. And with that, we need to actually interface our route to add it. So we would do router VRF SPBOIP, if I could type, and we would do IP route 0000000 since it's a default, and our next hop, wait 1, and then we want to enable that. So show IP route VRF SPBOIP. Now we should be able to ping .1, just like that. So what we want to do next, at this point, we want to configure our logical interface. And we also want to configure the tunnel source address, but just for IP shortcuts, and I won't be configuring that here, we'd want to give ourselves a loopback. Right. Perfect. So now let's configure our logical interface. So when configuring the logical interface, you have the logical interface ID, which could be 1 all the way to 255. We're going to start with 1 since we only have 1 right now, and then our destination IP. So the destination IP provided in the service ticket would have been the other side of this adjacency, which is going to be the .2 and that /30, which was provided, which in this case would be the VSP over here, which we have been tasked to configure, will be the .2. So we can go ahead and configure the .2, which would be 10.1.10.1.2. Logical ISIS tunnel source. Oopsie, router ISIS. I was doing this out of order. Got to give that tunnel source address. And that source address is going to be our IP interface in the SPB VRF. Oh, wow, that's no bueno. Cannot config in non-SPBM mode. Ooh. Oh, I did factory default this. I'm having a bad time. Oh, 1 second. So assuming that you have not actually configured any fabric parameters before you watch this video, you should do that by running the run SPBM config, since I forgot to do that. So oopsie daisy. Knowing that I have it configured now, we should be able to proceed with this configuration. So the run SPBM script just allowed me to go through the basic fabric parameters. So I could do show run mod SPBM, show run mod ISIS. It gave me a nickname. I've got my area. Then we've also got our source address, not assuming that we're using FEoIP. But anyway, now we can configure our tunnel address before proceeding with anything else. So we'll want to give our IP tunnel source address, which can be different from our IP source address, because remember, we're actually tying this to a logical interface. And so our source address is going to be the IP in our VRF. So if I do show IP interface VRF SPBOIP, we have made the tunnel source address 10.110.0.2, which is actually the IP interface in that VRF. So now if we do show run mod ISIS, we can actually see that is in there, and it is separate from the 169.20 loopback. And now we can do our logical interface. So again, back to our logical interface, I could actually do the ID of 1. Now, of course, I don't typically do a ton of these. So a lot of people usually will have like a dark fiber or some sort of T-uni. They don't necessarily need to have multiple logical interfaces. But you can do, for example, you can make this 15 or 151, however you want to do it. But anyway, our other side, like we mentioned before, is 10.110.1.0, which we know what we're going to give our VSP over there. So we'll just configure this, and then we'll do ISIS to enable it, ISIS SPB1 M1 to tie it to that SPBM instance, and then we'll do ISIS enable. So if I do show run mod ISIS again, we could see that logical interface exists there. So now I want to create a VLAN over here and tie that, since I do want to stretch this VLAN across our little fabric cloud here on our fabric network. I do want to create a VLAN on this side, and let's just call it VLAN create 60, and then name it data, because I like that. Port type 0, and then I want to tie an ISID to it, right? So VLAN ISID 60 200 060. Yeah, it sounds good. Show IP interface. We haven't given it an IP yet, so I'm going to interface that, and I'm going to do IP address 192.168.1.2 and /24. So if I do show IP interface, that interface is actually in our global routing table. If I do show VLAN ISID, we have ISID 20060 assigned to VLAN ID 60. All right, so now we could actually start our config on our Site2 Core VSP. First things first, turn off screen logging, because if you do that, you hate yourself. And since we do not have any fabric configuration, as you can see from these two modules, we'll do run SPBM. I don't change the ether type. I don't change the SPBM instance. I typically just follow the whole default. And since we already gave our SNMP name Site2 Core, it's going to keep that. Yeah, we'll enable multicast, definitely enable IP shortcuts. 192.168.169.31/32. There's our loopback. We do not want to configure SMLT. Don't need any MLTs. I do want content connectivity fault management, and we'll keep that level 4. So now if we do show run mod ISIS, we now have our ISIS configuration, just like that. Now we can proceed with configuring SPB over here. So remember earlier I said that this VPN concentrator is doing the NAT fragmentation. It's going over the public internet. 41.41.41.1 and then 58.58.58.1 routing for those two. And then there is a VLAN, so we're natting this 10.110.00/16 behind that. But anyway, long story short, this would be traversing the public internet, right? So this box is doing the fragmentation. These boxes are not doing any fragmentation of the sort. In fact, their ASICs aren't even remotely aware that there is any sort of fragmentation happening. So what we can do, and like I said, you could probably do that with a Linux box, like a little Raspberry Pi, but the biggest problem with doing that is that it's not, what should I say? If you don't have a specifically designed ASIC for fragmentation and reassembly, it'll be very slow, because if you're doing all of it in software, and the Linux kernel will do it natively, but if you're doing it all in software, it's going to be dangerously slow. Anyway, so if I do show VLAN members, we can see we've got our BVLANs and then VLAN 1. We want to create VLAN 20, name SPBOIP, type port type 0, create that SPB VLAN. VLAN members 20.1.1, port member, and then interface VLAN 20. Oh, forgot to create my VRF, IP VRF SPBOIP, and then interface VLAN 20. We do VRF SPBOIP. Now we want to give it an IP address, and remember we said that was going to be the .2, and that is a /30. So now if I do show IP interface VRF SPBOIP, we have a /30, and if you'll notice that it's down right now, but on the other side we could actually ping VRF SPBOIP source 10. You can ping .1, but we won't be able to ping .2, right? So as long as reachability is there, and just assume that there's reachability, we know it's down, so why can't we ping it? Well, we have an interface there, but that port is probably down. Yep. So we got that untagged. It's still down. Ping 210. Of course, this is totally a joke, but with these VMs, sometimes that makes things work. It just depends. Yeah. This happens a lot. Admin status is down. Yeah. I think it was 1.1. Let me look. Oh, that's right. It does not have LLDP. One moment. It literally was a VM bug. I just rebooted the box and it started working. Go figure. Yeah, there we go. So now it's up. So if I do show IP art VLAN 20 SVRF SPB OIP, we have 1.1, which is our IPsec concentrator. So that is operationally up now, and it's also administratively up because we are able to reach it. We have an ARP entry, so things are looking good. The unfortunate part is, I bet you we won't be able to ping it. Because if you remember, we're forgetting one thing. We need 10.1.10.1.2 to be able to know how to reach 10.1.10.0.2 or any other network for that matter. So we definitely need to have our IP route. So if I do router VRF SPB OIP just to interface that VRF, and I do IP route 0.0.0.0.0.0 10.1.1 wait 1, and then enable it. There we go. I bet you I can ping it now. It is alive. Cool. So what we do now is we need to specify our tunnel source address for FEoIP. I cannot stress this enough. It is in a different VRF because we do not want to use route maps or accept policies. Instead, we have to do IP tunnel source address 10.1.10.1.2 VRF SPB OIP. And then let's create our logical interface. And just for funsies, because I know a lot of people want to see this, I'm just going to call this logical interface 10. It does not matter. The destination IP is 10.1.10.0.2 ISIS SPB11 ISIS enable exit. And there is our adjacency. So if I do show ISIS SPBM ISID all, which that might take a minute to come up, show ISIS SPBM nickname. Okay, so we're learning that. Show VLAN ISID. We don't have any ISIDs. Okay. So I wanted to create our data VLAN over here. So VLAN create 60 name, and what did we said? Data type, port type 0. And then we wanted to do, I think I wrote it down. Yep, I did. So there's our ISID interface VLAN 60, and this is now our layer 2 VSN. We need to give it IP address 192.168.1.1/24. And as you can see, there's our ISID now. And if we do ping 192.168.1.2 in the global routing table, would you look at that? The reason that that worked is because we traversed the, as I showed earlier, we traversed the SPBM cloud and we made it to the other side. So if I come over here and show IP ARP VLAN 60, we'll see that we learned the ARP for the Site2 core fabric engine switch. And just like that, that is how you configure FEoIP. Now let's say that this was actually a backup path in the fabric and you actually wanted to do some traffic engineering to make it be an unpreferred path. What you could do is logical interface ISIS 10. We could do ISIS SPBM1 L1 metric, and we could enter our metric here to make it heavier or whatever. And then at that point, you know, we've now chosen a different path if we had multiple adjacencies. So, well, if you enjoyed this video, please give me a like and subscribe, and hopefully we'll do some more cool things like this in the future with some more extreme gear. Thanks for watching. Have a blessed evening.